We all know the universe is huge. But have you ever stopped to wonder what shape is it? Is it infinite? Does it curve back in on itself? Or is it flat, like a giant cosmic sheet? Today, we are going deep into one of the strangest and most fascinating questions in cosmology. What is the actual shape of the universe? First, let's define what scientists mean by the shape of the universe. We are not talking about the shape of the Earth or the layout of galaxies. We are talking about the shape of the space itself. How space is curved or flat on the largest scales, over billions of light years. To understand this, we need to think in terms of geometry, not just on paper, but in 3 dimensions, and even 4 if you count space-time. In geometry, there are 3 main types of curvature: flat, Euclidean. Parallel lines never meet. The angles in triangle add up to 180 degree. Positively curved or spherical, like the surface of a sphere. Lines eventually meet and triangles add up to more than 180 degree. The third one is negatively curved, hyperbolic, like a saddle. Lines spread apart and triangles angles add up to less than 180 degree. These rules don't just apply to 2D surfaces, they scale up to the entire universes. Okay, so how do we measure the shape of something we can't see from the outside? We are inside the universe, we can't zoom out and look at it from a distance. So instead, scientists observe light, specifically the cosmic microwave background, the oldest light in the universe, left over from the Big Bang. This light forms a kind of baby photo of the universe when it was just 380,000 years old. By analyzing tiny temperature fluctuations in this background radiation and how large or small they appear to us, we can infer the curvature of space. So here's the logic. If the universe is flat, the fluctuations appear at a certain angular size. If it's positively curved, they appear larger because light paths curve inward. If it's negatively curved, they appear smaller because light spread out more. So what do we see when we look at the cosmic microwave background? Satellites like WMAP and Planck have provided incredibly detailed maps. And the answer they give is the universe is flat, or at least very close to flat. And this is very important. We can't say it's perfectly flat. The measurements have margins of error. It could still be slightly curved, but on scales too vast for us to detect so far. The Planck satellite, for example, found that if there is curvature, it's extremely slight, less than 0.4% deviation from flatness. That means if the universe curves, it would take over 100 billion light years for that curve to become noticeable. So what does a flat universe mean for us? In a flat universe, the geometry of space is intuitive. Parallel lines stay parallel. Light travels in a straight line unless bent by gravity. And crucially, a flat universe implies an infinite universe, one that stretches forever in all directions. But that's where it gets weird. A universe can be flat and finite, depending on its topology. Kind of like a video game world that loops around on itself. So even if the geometry is flat, the actual structure could be something more exotic, like a 3D torus. Imagine if space looped around in all directions. So if you travel far enough in one direction, you would eventually return to your starting point. Let us explore the other 2 options. Positively curved universe. Like the surface of a sphere, if this were the case, space would be finite. There would be no edge, but traveling in a straight line long enough could bring you back to where you started, like flying around the Earth. Then we have the negatively curved universe, like a saddle or a Pringle chip. This universe would be infinite too, but the geometry would be very different. Parallel lines diverge. Space would expand faster. It might look more chaotic on larger scales. Some early data hinted at a slightly curved universe, but the current consensus is flat, or at least so close to flat we can't tell the difference. You might ask, why does this even matter? Because the shape of the universe tells us about its past and its future. A positively curved universe might eventually collapse in a big crunch. A flat universe could expand forever. A negatively curved universe might expand even faster, driven by the dark energy. It also tells us about the amount of matter and energy in the universe, something that connects to dark matter and dark energy. So, what is the shape of the universe? According to what we know now, it's flat. But the truth is, we still don't know everything. The universe could hold surprises beyond the observable horizon. It could be shaped in ways we can't even imagine yet. And that's what makes science beautiful. Every answer leads to more questions. So, what do you think the shape of the universe is?